Greetings, my young students. Today we will be exploring gravitational potential energy. And here I have a contraption that will help me demonstrate this. This is also a great illustration of the change of the gravitational potential energy into kinetic energy as well. What you're going to need today is you will need a calculator. You need your energy, the nature of energy packet that you have, because we are going to turn to page 71, because this is what discusses what is gravitational potential energy, and you'll be able to see an example on how to calculate them as we do this demonstration. I also have a meter stick that will allow us to take measurements to determine the height of the object. I also have several objects here. They're balls. We are going to use a ping pong ball at 2.2 grams. We're going to use a yellow ball at 8.6 grams. We'll use a wooden ball at 20.1 grams and a green ball at 63.2 grams. Now, in our calculations, it says that we need to do this in kilograms. So what I have done is I have made a little table here for you to see that what we need to do is that we need to move the decimal place on these three spots, so we can see that the ping pong ball that weighs 2.2 grams is really 0.0022 grams, and we need to make those adjustments for each one of the objects. The yellow ball will be 0.0086 grams. The wooden ball will be 0.0201 grams, and the green ball will be 0.0632 kilograms. So each one of these calculations will be done with kilograms, as is the height will be calculated in meters. What I would like you to do is I'd like you to construct a data table. As you can see, here I've done an example of one where I have the object listed and it's math, so we can just do the calculations each time. Because gravitational potential energy is calculated by taking the mass of the object, multiplying it by the acceleration of gravity, which is 9.8 meters per second squared, and then multiply it by the height in meters. So although I'll be measuring in centimeters, I will just convert them into meters by moving the decimal point, and we'll be able to calculate our final product, the gravitational potential energy, in joules. If you look in your packet, you will see that there's an example where it has a 7 kilogram object and it is at a height of 4 meters. So they do the calculations for you there. Here, the first one we are going to do is the ping pong ball. And we're going to figure out, our goal today is to figure out how much energy it takes to complete the loop cycle, because it's going to require so much energy to get through all 2 of these loops and come out and hit the cardboard on the other end. The first object that we are going to use is the ping pong ball. So we know that the mass of the ping pong ball is 2.2 grams. We're going to convert that to kilograms. That'll be 0.0022 kilograms. And we are going to multiply that by g, which is the acceleration of gravity, and it's constant. We're always going to multiply by 9.8 meters per second squared, because the acceleration of gravity is constant. So we can set up the equation so far where we've got gravitational potential energy equals 0.0022 kilograms times 9.8 meters per second squared multiplied by the height. So we will start off with our first trial with our golf ball, or excuse me, our ping pong ball at 0.35 meters. So the height is 0.35 meters. And we are going to let this go. And is there enough gravitational potential energy to change into kinetic energy to go through the loop twice and come through and hit the ping pong ball? So here is what's going to happen. I'm going to let this go in 3, 2, 1. As you can see, that was not enough energy to get through the loops. So how much energy was that? Well, when I put that into my calculations, I will take 0.0022 times 9.8 times 0.35, okay? 0.0022 kilograms times 9.8 meters per second squared times 0.35 meters is what we'll plug in to get the amount of gravitational potential energy in joules. And I come up with 0.00756 joules. So here we go. I've got 0.07546 joules. I did that on my calculator. So as you can see, that wasn't enough energy to complete the loops in this circle. So what we're going to try next is to see if a higher, if I increase the height, because when we read here about gravitational potential energy, that it depends on two things: the object's mass and its height above the ground. So what we're going to do is we're going to increase the height, because those are the two variables that we can change. We can change the mass, which we're not, and we're going to change the height. So we'll place the ping pong ball at a height of 0.45 meters. So what we can do right now is we can actually calculate if at this height of 0.45 meters, how many joules of energy that we have in the gravitational potential energy. So we got 0.0022 times 9.8 times 0.45. And now I have going to 0.09702 joules. Okay? So here's my calculations already, and the question is this enough energy to have this object complete this track? So here we go. In 3, 2, 1. Almost. That was almost enough energy to come all the way around and complete one complete revolution. As we have the ball sitting here, we have gravitational potential energy. As soon as I let go, the gravitational potential energy begins to decrease as the kinetic energy begins to increase. And there comes a point where there is no more potential energy, and it's the kinetic energy that takes it up and around. Let's try another sphere with a little bit larger mass. We will now go to the yellow ball, and it has a mass of 0.0086 kilograms. So we can put that into our calculations. I've got 0.0086 kilograms times the constant of G, which is 9.8 meters per second, times our height. So in our first try, we were at 0.35 meters. Let's try that one again and see if we can be a little bit more successful. So I'll hold my meter stick here. I'll get the bottom at 0.35 meters, and I'll let it go in 3, 2, 1. Oh, that was almost enough energy to complete this track. Let's calculate how much gravitational potential energy that one has. So I've got 0.0086 kilograms times 9.8, the constant of the acceleration of gravity, times 0.35. And this equals 0.0295 joules. Okay, I rounded. So here I've got 0.0295 joules, and we can see that we've increased the mass of our object, but we returned to that same height of 0.35 meters, and we were almost enough gravitational potential energy to complete the circuit. So what we are going to do is we're going to move the yellow ball to 0.45 meters, which is up to the top, and we can calculate the gravitational potential energy and see if that is enough to complete the circuit. So I got 0.0086 times G, which is a constant, 9.8 meters per second squared, times 0.45. And that equals 0.0379 joules. So here we go. At this height, because the mass hasn't changed, I've just increased the height. I now increase the gravitational potential energy. So we'll let this go in 3, 2, 1. And at this increased height, we now have enough gravitational potential energy to transfer to kinetic energy to complete the complete circuit on this track. From here on out, I'm going to require you to make the calculations. Our next object will be the wooden ball. We will place the wooden ball which has a mass of 0.0201 kilograms at a height of 0.35 meters. Take the time and calculate how many joules, and we know that just about 0.03 and some change, it was enough to get through there. So let's see if this, with more energy, if this object is able to complete the circuit. We will let this go in 3, 2, 1. Okay? At that height, we didn't have quite enough to complete the entire circuit. So what we will do now is move the object to 0.45. And will this object at this height have enough to complete the entire circuit? Let's try it. We now have the mass of 0.0201 kilograms multiplied by the constant of G, which is 9.8 meters per second. And we are at a height of 0.45. So we will let this go. And you can see we had plenty of energy to complete this circuit. Now we will move to a green ball. The green ball has a mass of 0.0632 kilograms. We will set this object at a height of 0.35 meters. So you can calculate how much gravitational potential energy this object has at this height. And you do that by multiplying the mass, 0.0632 kilograms, times 9.8 meters per second squared, times 0.35. And we will let this go and see if we have enough gravitational potential energy to complete the circuit. And we did. This time, I'm going to move the sphere a little closer to see if we can find that spot where it's not enough gravitational potential energy to complete the circuit. So we're going to move this down to 30. So here we are at a height of 0.30 meters. We can calculate the gravitational potential energy by multiplying the mass of the object, 0.0632 kilograms, times the constant of the acceleration of gravity, 9.8 meters per second squared, times the height, 0.30 meters. Calculate the amount of gravitational potential energy, and is this enough for this object to complete this loop? We will find out in 3, 2, 1. It is not. So just that small change in the height of the object reduced the amount of gravitational potential energy to not give it enough kinetic energy to complete the circuit. Let's see how much energy we will have at 0.45 meters. The same object, the green ball, with a mass of 0.0632 kilograms at a height of 0.45 meters, and see if it should be able to complete this. We should have more gravitational potential energy because we have increased the height. Go ahead and perform those calculations. You should find that there is a greater amount of gravitational potential energy. And when we let this go, we should have enough energy to complete the circuit. In 3, 2, 1. As you can see by these demonstrations, gravitational potential energy is affected by two things: the mass of the object and the height above the ground the object is. Calculating this can help us determine for another mass exactly how much energy it takes to complete a full circuit. And then we can determine the mass and calculate the specific height for the loop to figure it out. Ladies and gentlemen, I want you to make sure that all your work is shown on your paper. What I'd like you to do now is answer all the questions in the margin of this packet on the other side of this paper. Do questions 1, 2, 3, 4, 5, 6, and 7. Then I would also like you to do questions 1, 2, and 3 on the back side. You'll have the rest of the period to do this. Turn this sheet into the colored trays at the end of the period. We'll see you tomorrow.